Hello everyone, welcome back to your channel, and I'm sure you guys are doing good today. Today I'm going to teach you how to find the last digit of any expansion, basically the last digit of any multiplication. In short, you might see questions like unit digit, alright? So we call it as the last digit as well. The question is going to be something like this. Let's say if I have something 237 to the power of probably 732. What's going to be the last digit of this power, this exponential function, exponential number? Before I go ahead and teach you how to solve it, let us understand the basic multiplications and how to find the the last digit of those basic multiples. For example, for instance, if I have, let's say, 26 times probably 34. Now if I do the normal multiplications, what I'm going to get is it's going to be 6 times 4 24, carries 2. 4 times 2 8 plus 2 is going to be 104. Likewise 18 is going to be 78. Now it's going to be 4 8 and 8. Can you see one thing? The last digit does not change, it comes down as it is. So next time if someone asks you what's going to be the last digit of multiplication of these two numbers, what are you going to do? You're going to just multiply the last two digit, that's 6 times 4, that's 24, and 4 is going to be the last digit. Yeah, simple one, right? In case even if you don't know this stuff, you can just probably go ahead and multiply and get the last digit. Now the idea is, if we have the big numbers, what are we going to do? So before we do that, let us understand some properties of the number, the way they repeat themselves. The first thing which you should know, for example, 2 to the power of 1 gonna give you 2, right? 2 to the power of 2 is gonna give you 4, and 3 is gonna give you 8, and 2 to the power of 4 is 16, but the last digit is gonna be 6. Now if I go ahead and write 2 to the power of 5, that's gonna be 32, but the last digit is gonna be 2. Can you see the number is repeating itself after a gap of 4? Yeah. Now 2 to the power of 6 is going to be how much? Something around 64. Well, the last digit is going to be 4. You can see it's repeating itself. So the number repeats itself after a gap of 4. So we can actually generalize this and write down to basic information that every even number to the power of integral multiple of 4 will end up with 6. And every odd number to the power of integral multiple of 4 gonna end with 1. We have two exceptions over here, and those are 5. No matter what you choose the power of 5, it's always gonna end up with 5. And if you're gonna choose 6, anything on 6 will also gonna give you 6. So these are the couple of basic rules that you should be knowing before we can tackle these kind of questions. Alright, now the idea is I need to write the numbers as the power of in multiples of 4. There are two reasons for that. One, it repeats itself, and that's going to help you in easy calculations. Now, if they ask you questions like that, what you need to do, you need to understand one thing: the last digit of this expansion going to be same as 7 to the power of 732. Okay, still it's a big number, right? You can just use a calculator and get the value of the last digit of that. So what we need to do, we need to write down this number as a multiple of 4. And in case if I'm getting some remainder, I would not hesitate writing that remainder as well. Now we have an advantage over here. I know that a number is going to be divisible by 4 if the number formed by the last two digits is a multiple of 4. Well, I have taught all this stuff in my fundamental number system. You can just go ahead and check the video. Alright then, okay. If I divide 32 by 4, I'm sure it's going to be divisible by 4 for 8 times, right? I'll not be having any remainder as of now in this particular question. So I can right away say that it could be written as 7 to the power of integral multiple of 4 without any remainder. Now, we know that any odd number to the power of 4n should end up with 1. 7 being an odd number with a power of 4n should end up with 1. So that's how we're going to get the last digit of this expansion. Now let us try with a number where we get some remainders as well. Probably I'm going to choose 230, probably 4 to the power of, let's say, 234 itself. All okay? Okay, when I look at this number and divide 34 by 4, I'm sure you guys will agree that remainder is going to be 2. So what I'm going to do, I'm going to put up this number in this form. It's going to be 4 to the power of 234. That's going to be the last digits, of course, you know, and that's going to be 4 to the power of, if I look at this number, when I divide this by 4, the remainder should be 2. I can write it's going to be 4n plus 2, where this represents the remainder when this entire number is divided by 4. Alright, because when I divide 34 by 4, remainder comes out to be 2, and that's going to be the remainder for the entire number as well. That's the theory behind divisibility with 4. Now I can use the exponential format over here. I could write 4 to the power of 4n times 4 to the power of 2. Well, that's a basic exponential, you know, process. Now I know this is an even number, and we have already seen even number to the power of 4n would end up with 6. It means this number is going to end up with 6, and I'm sure you guys know 4 to the power of 2 is how much? 16, and the last digit of 16 is 6. 6 times 6 is going to be 36, and the last digit comes out to be 6. Simple, isn't it? Yeah. So let us do a quick example how we can save time, and probably, you know, we can go ahead solving in a very quick span of time. Let me choose a number, let's say probably 4, 20 and 9. Let me have, let's say 4, probably, you know, 30. All okay. Now maybe I can choose to have, let's say 31. Okay, fine. Now the last digit of this should be 9 to the power of 431. Now guys, tell me, if I divide 31 by 4, how much should be remainder? Definitely it's going to be 3. So it's going to be written as 9 to the power of 4n plus 3, and that's going to give you how much? 9 to the power of 4n times 9 to the power of 3. Well, this being an odd number to the power of 4n should end up with how much? 1. Well, 9 to the power of 3, probably you don't know how to, you know, it's going to be a big number. So what I can do is, I could actually split this as 9 to the power of 3 as 9 to the power of 2 times 9. Well, we know 9 to the power of 2 is how much? 81, and the last digit being 1, times 9 should end up with 9. Well, that's going to be 9. So the answer is going to be 9. Alright, yeah. Now the idea is, when I divide any number by 4, remainder can maximum be 3. It can be probably 0, 1 and 2 and 3. And you know, any unit number, you know, any unit digit can be probably expanded till power of 3. We know we can do that. Okay, fine. Now the second part of this kind of question is, they might put up a lot of multiples, and then they might ask you how to find the last digit of those multiples. Let us say, for example, if I have, let's say 234 to the power of probably 234 times 235 to the power of 235, let's say 236 to the power of 236. I can apply the same basic rules, you know. Now over here it should be 4 to the power of, when I divide 34 by 4, what's the remainder? Well, that's going to be 2. I would write 4n plus 2 times 35. 5 to the power of anything I've told you, it's going to be how much? 5 itself. So I'm not going to waste my time. I would just write the last digit of that should be 5. 6. Again, we have two exceptions, you know, over here. 6 to the power of anything going to give you 6 itself. Now the idea is, do I really need to do this step? The answer is no, we don't have to, you know. The reason is, I know 5 is an exceptional number which always going to end with 5. 6 again follows the same rule, it's always going to end with 6. And probably you know that 6 times 5 is going to give you 30. The last digit of this multiplication should be 0, and probably 0 times of anything will also give you 0. Simple one, right? Yeah. So lot many times they just want to trap you with these kind of numbers, and being a smart guy, you should not get trapped. You should not being bullish and start solving each and everything. What you need to do, you're gonna focus on some, you know, important numbers out there, and if you can figure out some tricks and all, well, you know, you're gonna save some time and you're gonna get it done quite easily. Okay, so that was how we can find the last digit of any expansion. Now I'm going to teach you very quickly today how to find the number of factors and, you know, number of sum of those factors in a quick succession. For example, you need to understand two things about the factors, and one more terms that we can come across is prime factors. Let's, for example, small number, we have 12. Factors of 12 could be 1, could be 12, could be 2, 6, 3 and probably 4. Yeah, so the factors are the numbers which can divide a bigger number. Okay, let's say for instance, if I write m equals a times of n, where a is an integer, it means a is a factor of m. At the same time, even n is a factor of n. Multiple, as we all know, it's a basic word. It's a bigger value. It's a bigger value which we obtain by multiplying certain number of things. So m is a multiple of both a and n, and these a and n are the factors of m. That's the meaning of multiples and factors. Now we have two kinds of factor. One being normal factors, other being prime factors. Idea is very simple. The factors which are prime are called prime factors. So here we have 2 and 3 being prime numbers. And I'm sure you guys agree that 1 is not a prime number, it is just an ordinary odd number. Again, I have made a video on the number system. If you guys get some doubts over there, please go and refer those videos, and you can let me know if you still remain with some sort of doubts. Okay, so this was a pretty small number, so I was easily able to find the number of factors and then the number of prime factors. What if the number is bigger one? Probably if I ask you to find the number of factors of 1200, that's a huge number, right? If I go ahead with this method, probably going to take a lot of time, So let us understand the rules how to find the number of factors. It includes two basic standard rules. So guys, just note it down. Rule number 1, that is write down the number in its standard form. Standard form. Now I can tell you what is the meaning of standard form. So basically what we do, we just write the numbers as the multiples of its prime factor with their powers. Okay, I'm going to choose the same number. We can verify that as well. So 12 could be written as 2 to the power of 2 times 3 to the power of 1, isn't it? 4 times 3 is going to be, and these are the prime numbers. So what I'm doing exactly over here is I'm writing 12 as the multiples of the prime factors along with their powers. Step number 2, that is, I would write step, that's going to be a better word for this one. So step number 2, what essentially we're going to do over here is we're going to add 1 to the powers of the prime factors. And let me repeat one more time. We're going to add 1 to the powers of the prime factors, powers of prime factors, and multiply them. Let me just demonstrate that for you. So what we have over here is I need to add 1 to the power of prime factors. Well, the power of 2 is how much? 2. Let me add 1 to this. So what I'm going to do is I'm going to add 1 up to this 2. Alright. Now the next prime factor is 3 and its power is 1. I'm going to add up 1 to the powers of 3. Well, that's going to be 1 plus 1. And then I need to multiply them. Okay, let me put this sign. I'll be having 3 times of 2, and that's going to yield you 6. Now let's cross verify this. How many factors do we have? 1, 2, 3, 4, 5 and 6. Well, that's matching, isn't it? Clear enough? So that is how we find the number of factors of any number. Okay, let me give you a big example. Probably we can have a numbers with more number of zeros. Let's check if it works properly and easy way or not. Okay, fine. The basic one. Example 1. If I ask you to find the number of factors of, let's say, 100, that's a pretty easy number. Let's say the 100. The first step involves writing the number in the standard form. Okay, fine. That's going to be pretty easy. 2 to the power of 4 times 5 to the power of 2. That's going to be 4 times 25. That's going to be 100. Step number 2. Let us add 1 to this. That is 2 plus 1. And then I'm going to add probably 2 plus 1. Multiply them. I'll be having 3 times 3. And that gives me how much? 9. So 100 will have 9 number of factors. Okay, fine. Let us go with one more example, and we're going to try and do it very quickly. We have 1200. So my suggestion to you guys, this could be seen as 12 times of 100. Reason is very obvious. We know how to write 100. That's going to be 4 times of 25, isn't it? Yeah. 2 to the power of 2 times 5 to the power of 2. And now we know how to write 12. That's going to be 2 to the power of 2 times 3 to the power of 1. And this 100 is a familiar number. Well, I'm going to write such way. Now I would just do little sort of simplifications over here. Well, that's going to be 2 to the power of 2 plus 2. Well, going to be 4. 3 to the power of 1 will remain same, and 5 will hold the same value. Step number 2, I'm going to add 1 to the power of 2, 1 to the power of 3, and I'm going to add 1 to the power of 5, and finally we're going to multiply them. Well, that could be written as this way: 4 plus 1 times 1 plus 1 times 2 plus 1, and we need to multiply them. That's going to give you 5 times 2 times 3, and that's going to be how much? 30. So we have 30 factors of 1200. All clear? Alright, then the next part of these kind of questions is going to be how to find the sum of those factors. Okay, I'm going to start with the 12 itself so that we can actually verify them and get some more confidence. Fine, let me have this 12. I know 12 factors are 1, 12, 2, 6, 3 and 4. If I really want to know the sum of these factors, I can add up 1 plus 2 plus 3 plus 4 plus 6 and then plus 12. The basic rule of addition. 12 plus 6, 18, 18 plus 4, 22, plus 3, 25, plus 2, 27, plus 1, it's going to be 28. Let me check if I'm right or not. Yeah, it's going to be 10, 10 plus 5, 15, 16 plus 12, 28. That's cool. Okay. Now, let's say how to solve it in some process. What we do, we just write the numbers 12 in the standard form again. Step number 1, write the number in standard form, 2 to the power of 2, 3 to the power of 1. Okay guys, next step is going to be a little the most important part. So understand this properly. I'm going to be a bit slow as well. So what we do, we start writing the first prime factor as 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2, and now I'm going to stop. Why? Because the maximum power that we have over here is 2. Same process I'm going to do with 3 to the power of 0 plus 3 to the power of, probably it's going to be 1. Yeah, and I'm going to stop because we have the max power is 1. Let me just evaluate this. Okay, definitely I'm going to multiply them. Well, that's going to be 2 to the power of 0 is 1. That's going to be 2. That's going to be 4. This is going to be 1 plus 3. You can check it's going to be how much? 7 times 4, and we're getting 28, isn't it? Simple one, yeah? So these are the quick ways to find the sum of the factors of any number. So now let us try with a different number. We have chosen 100 in the next example. Let us continue with that. Well, let us take this example number 1. Now we have example 2. I just really want to find the sum of the factors of 100. All cool? Well, I know it could be written as 2 to the power of probably 2 times 5 to the power of 2. The next process is going to be same what I did over here. I would just start writing 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2, and I'm going to stop because the power is 2 over here. Now the next is I'm going to put the multiplication sign, and I'm going to work on the 5 as well. That's going to be 5 to the power of 0, 5 to the power of 1, and here we stop because the maximum is 2. Cool. Now let me just evaluate this. 2 to the power of 0 is going to be 1, 2 to the power of 1 going to be 2, and that going to be 4. The same process as well over here. It's going to be 1 plus 5 plus 25. Oh, that's a huge number, isn't it? Now we have 7 times 31. Okay, eventually it is going to be a really easy number for all of us. So the sum of the factors of 100 is 217. I'm sure you guys would have understood this. If not, try and repeat repeat the video and try and get it done. Okay, I'm going to do one more example, last example, to find the sum of these factors. Alright, then I had a number 1200. Well, that's going to be written as 2 to the power of 2 times 3 to the power of 1 times 2 to the power of 2 times 5 to the power of 2, which gives me 2 to the power of 4 times 3 to the power of 1 times 5 to the power of 2. The process is going to be the same. I'm going to write 2 to the power of 0 plus 2 to the power of 1, 2 to the power of 2 and 3 and 4. We're going to stop. The max power is 4. We're going to stop there. Now let's talk about 3. 0 plus 1, we're going to stop, times, I would write it here, 5 to the power of 0 plus 5 to the power of 1 and plus 5 to the power of 2, and of course we're going to stop there. Now we're going to just calculate this. It's going to be 1 plus 2 plus 4 plus 8 plus 16. Okay, fine, no issues. We're going to have the next part. It's going to be 1 plus 3. All right, then it's going to be 1 plus 5 plus 25. Oh, huge numbers, Now let us add this up. 16 plus 4, 20. 20 plus 10, 30. 30 plus 1, 31. Cool. 3 plus 1 is going to be 4. It's going to be 31. Now 31 times 4 and times 31. So basically what we have over here is 31 whole square times 4. Alright, okay, fine. Since the square has come, I'm going to teach you how to find the square of this number as well. Okay, let's do this. 31 square. For that you need to understand this basic formula, a plus b whole square, which is a square plus 2ab plus b square, isn't it? So what we're going to do now over here is I'm going to put up 31 as 31, and I would actually resemble 3 with a and 1 with b. I would start with the right hand side. Assuming that b is 1, what's the value of 1 square? Yeah, it's gonna be 1. Alright, let it be. I'm not gonna put this positive sign over here. Now I'm gonna multiply up a and b, which is 3 and times 1. That's gonna be 3 times 1 gonna be 3 times 2, that's gonna be 6. No carry forward. A square, that's gonna be 3. 9 square. Alright, then I got the value of this square, 961. Is that clear to all of you? If not, let me take one more example for you guys to understand how to find the square. I'm gonna cover up all this stuff in another video in separate. For now, let's say I want to know the square of 26. I'm gonna follow the same basic formula. This I would resemble as b, this I would resemble as a. Now b square is how much? 36. Carry forward is 3. Keep it in hand. A times b, 6 times 12, 2 is gonna be 12. 12 times 2 gonna be 24. What was the carry forward? 3. 24 plus 3 is gonna be 27. Carry again gonna be 2. A square, 2 square is how much? 4. 4 plus 3 is gonna be 7. So square of 26 is gonna be 7, 7 and 6. I'm sure you guys would have understood this by now. In case not, let us choose probably one more number. Let's say 46, or maybe I can choose to have, let's say, 47 square. Same formula, I'm gonna be opt over here. It's gonna be a square plus 2ab plus b square, where b for me is 7 and a for me is probably 4. 7 square, 49. Carry forward is 4. You can use your fingers to count those, keep those carry in the mind. Okay, let me write it properly. The handwriting is getting worse. Okay, 7 square is how much? 49. Carry is 4. 7 times 4 is 28. Times 2, 56. 56 plus 4 is going to be 60. Carry is going to be 6. Keep it in hand. 6. 4 square is 16. 16 plus 6 is going to be how much? 2 and 2. Well, that's the square of 47, isn't it? Yeah. Cool now. So, I had the square of 31. Well, that was 961. Times 4, I can easily multiply. 4 times 1 is 4, 6 times 4 is 24, carry is 2, 36 plus 2 is how much? 38. Well, that's gonna be the sum of the factors of 1200. I hope you guys have understood how to find the last digit, how to find the square of any number, and how to find the sum of the factors of any number.